So welcome to this afternoon's masterclass on heat pump design. My name is Chris Whitelock, MD and owner of Pure Renewables based in Hull, and we've been installing and designing heat pump systems since 2007 when we started the company. So let's begin. Okay, Pure Renewables are accredited specifiers, suppliers, designers and installers of air and ground source heat pump systems, heating distribution, including underfloor and smart radiators, mechanical ventilation heat recovery, known as MVHR, and solar PV and solar thermal. We were established in 2007, and our core values which underpin everything that we do are responsibility, integrity and excellence. We're multi-award winning, as you can see from the list there, and we're experienced in new build and retrofit systems, light commercial, leisure industry, office and retail, community projects and private and domestic. And I list all those things really just to give you an idea of the context of our experience that we've gained over the years. So in today's masterclass, we're talking about the critical nature of design. And the old adage goes, failing to plan equals planning to fail. Or another one, measure twice and cut only once. So design and planning are critical and key in everything that we do and approach, in our approach with heating systems. Now, heat pumps work in a variety of situations, and it's quite a wide variety, and it includes domestic properties, office blocks, high-rise apartment blocks, hotels, factories, greenhouses, and I'm talking about the big horticultural ones, and even whole villages can be heated by heat pumps. And in fact, a heat pump, to be honest, can work pretty much anywhere as long as it's been well designed to work with that particular application. But as I said before, it all comes down to good design. And so today I'm going to focus on what goes into designing a good heat pump system for your home. These are the steps we take when designing a system. So first of all, the place where we start will be having a discussion with the customer, with you, to find out what you want from your system. Because there's no point in us second guessing, making assumptions, because we'll likely get it wrong. And that won't be good for any of us. So yeah, we always have an in-depth discussion with the customer. First of all, probably over the phone, and then as the thing progresses, we will come out and do a site survey and meet you and talk to you face to face with COVID arrangements in place, of course. In the case of a new build or renovation where there are plans available, we would ask for copies of those plans, and that's really, really important because that gives us an opportunity to do very in-depth heat loss calculations, room by room heat loss calculations, which again is critical to making sure that we're getting a good design of system for you. If it's a retrofit system or situation where there's no plans available, then we would want to come out and do a property survey to dimension the rooms and get information on the insulation in the property, for example, window sizes, etc., etc. So we do go into some depth in terms of the information that we get to be able to do a good heat loss calculation for you. Then from the plans and the survey, we conduct room by room heat loss calculations. This determines the size of heat pump required, and just to the right there you'll see a sample spreadsheet which details all the different parameters that we need to put in to come out with a system size for you. So we would be putting in the room dimensions, window dimensions, the insulation U values, which if you don't know what that is, that's the amount of heat and the rate that the heat passes through a structure or a surface or a building fabric. And basically we need to have those U values and work to those U values to make sure that a heat pump system is going to give you the required amount of energy to keep the building warm. Basic principles of heat pump system design. First of all, the better insulated the property is, so the more efficient the system will be, and that we always start with that premise that it's all about keeping the energy within the building and reducing the amount of heat loss from that building as much as we possibly can. And that's going to have a positive effect whatever the heating source is. So whether it's heat pumps, boilers, whatever it may be, insulation is absolutely critical in a building to make the building efficient, if you like. Secondly, correctly size emitters. So as radiators and underfloor heating are critical in getting the most out of your heat pump. I liken this to a car with a very efficient engine but flat tyres. Means that you're not going to get the efficiency out of that engine that you really should be getting from it. So keeping the tyres inflated at the proper rate means that that car will run more efficiently. So it's the same with radiators or underfloor heating in a property, is that you can have a heat pump that as a heat pump entity in its own right will be very efficient, but if it's not able to emit the heat into the building in an efficient manner through efficient emitters, then it's not going to work that efficiently. So correctly sized emitters is absolutely critical. And in quite a lot of cases, with retrofit situations, we would be looking to upsize or upgrade the radiators in the property. Thirdly, heating distribution pipework is also important. The heat pumps work at low temperatures. They're not like a boiler, which will be kicking out 75, 80 degrees. Heat pumps typically will be having a flow temperature of 40 to 45 degrees. And because of that, it's critical that you are getting good flow rates to transmit or transfer that heat through the system. If your pipes are too small, or if, for example, it's in an older system where the pipes have become furred up and the bore has closed up, then your flow rates are going to suffer as a consequence of that, and therefore the amount of energy emitted into the room will also suffer accordingly. So you can upsize your radiators all you like, but if your pipework is poor or it's too small, then those emitters are not going to work anyway. Fourthly, it's critical to think carefully about the siting of particularly an air source heat pump with regards to noise and aesthetics, for example. Depending on the property, if it's listed for example, or in a building conservation area, you will require planning permission to put an air source heat pump in. Or if you're putting in more than one unit, you'll require planning permission, regardless of whether the house is listed or not. With ground source heat pumps, technically you should also be talking to your planning office and telling them what you're putting in, and it may be that you require planning permission for a ground source heat pump system to make sure you're not putting your ground array into an area that may be developed on in the future. So what can go wrong when a heat pump is misspecified? Well, first of all, the property likely won't get warm. So during the winter months, you will be cold. Secondly, ground loops can freeze. If a ground loop is underspecified, and therefore there's not enough pipe in the ground to be able to supply the energy that the heat pump needs to supply energy to the house, then we get what's called over extraction from the ground, and we can end up with going into negative temperature figures on a ground loop, and it starts to freeze, which is not very good. It freezes the ground, and that in effect is your petrol tank is the ground. So if you're freezing that and taking that down to minus temperatures, then you're not going to get the energy out of that ground that you need. And also actually freezing the system is not good for the system itself anyway. Thirdly, run costs can therefore skyrocket. And there's been a lot of horror stories in the past about heat pumps costing a lot to run the earth, no pun intended, and that's simply because they have not been well designed. When a system is well designed, however, you can significantly reduce run costs of heating a building. So I'm just going to go through and show you some pictures now of some of the installs that illustrate different heat pump systems. This one here is what we call a cascade heat pump. So it's two heat pumps in cascade, and you have in effect a master and slave arrangement. This would be for typically a large domestic property, or in this case like a commercial situation, where you won't have enough output from one heat pump, so you have to marry it up with another one. The other thing actually on that point is to decide or understand whether you've got single phase electricity supply or three phase. Single phase will limit the amount of output from a single heat pump, as in this case, so we had to go to two heat pumps because the heat requirement was greater than the limit from one heat pump. Three phase, however, means that you can go to much bigger single heat pumps on a three phase supply. So if this property, in this case, had a 3-phase supply, we would only see one heat pump there. This is an illustration of before and after the ground loops. And so we can see on the left a picture of trenching works with the ground loop in it. And then 6 months later, the same area of land, and you can hardly tell the ground loops are in there. So the land does recover quickly, and it's remarkable actually how quickly it does recover, and that you will be none the wiser. Nobody will be any the wiser that you've got pipes underneath that ground extracting heat for you, which is fantastic. So yeah, just thought it was a good illustration there of a before and after situation. This is a picture of an air source, typical air source heat pump on a private domestic dwelling. This dwelling itself is actually quite an old cottage, and it was extensively renovated. It had double glazing put throughout, and it was insulated very well. And so an air source was put into this property, and it works very well. In fact, this air source has also, this property's also got solar PV connected to it. So the PV is contributing to the running of the heating. And that's beginning to get to the scenario where you've got a truly renewable heating system, and we're decarbonising in effect the heating grid. This was a heat pump that went into a golf club, and again we actually went under some of the fairways with that system. And this is Poppleton Park and Ride near York, and there was a commercial ground source heat pump that went into that to heat that building. This is a end of terrace house that we put a air source heat pump into, and helped this property to become Hull's first super home in achieving zero running costs. Now, this was a typical Victorian end of terrace house that the owner, who's pictured there, did a lot of work to in terms of upgrading the insulation of the home, putting solar PV on, solar thermal as well, and then complemented by a heat pump, which was doing the hot water and the heating for him. And he's actually receiving more back from the grants that are available than he's having to pay on his electricity. So after all that, you may have some questions. It would be wonderful to meet you in our virtual lounge and camera to camera. And so please do join us there, and hopefully we can field any questions that you may have. Thanks for listening.